Alright, so in this video, we're going to take a look at how to use the pop attract and interact node to create a school of fishes. Okay, so this is the final result that we'll get. Alright, so let's get started. Right, so I have a new Houdini file, and what we need to do is firstly we need to have an object that is sort of randomly moving, or you can just manually animate it as well. So what I'll do is I'll just take a sphere and I just want a single point, because I don't want multiple points. I just want one point. So I'm just going to take a primitive sphere, like we won't change it into polygons or anything, and then take a transform. And what you want to do is right click on the translate, like not on any of the values, on the translate itself, and come to motion effects and give it noise. Okay, and this will apply, like it will generate a chops network and it will give it noise. Okay, so if we look at it, like if I zoom out a bit, you should get something like that. Now that's too random and crazy. So we're going to make a few changes. So I'm got the amplitude down to 5, which means it is moving within a range of 5 in all three axes, like +5, -5. And we lower the roughness a lot. We will lower the exponent, so it kind of moves a fair bit. And then I'll just increase the period to kind of make it a little slower. So I'll have this. Okay, like I can maybe lower that a fair bit. If you want to change the seed for each one, like it's kept to per channel, so we can just add a value to that. So as you keep adding a value, you'll keep getting a different result. So if you don't like this result, you can just add a value here and change the result. Okay, so this is fine. We have our basic thing done. Now let's get started. Okay, so we'll take the original sphere itself, like this guy over here, and I'll plug that into a pop network. So we'll just take a null and I'll call this as out emit, and this will be the attract. Okay. And so this comes in here and this goes in there. All right. And we want a fixed number of points. So I'm going to keep it to impulse activation, and we'll do $ff equal to 1. And let's do 100 points. The lifespan doesn't matter because we want it to remain forever. Okay, then the first thing we do is we take a pop attract and we will set this to points, and we can set it to second context geometry. And it can remain on average position or per point because we only have 1 point, so it doesn't matter. And if you press play, you'll start to see it move, which is good, which is basically what we want. Now we can increase the intensity a little. So let's get it to around 3 or 4. Now we don't want it to exactly follow the object. It should just pick up the motion. Like that's generally what we want. Now what I want to do along with this is also give it a little bit of randomization. So let's pick up Vex expression and we can just do randomize force scale and make it between say 0.5 and 1. So you'll get a little bit of randomization, which starts to look a little better. Okay, and maybe we can increase this a little bit more. Yeah, I think that's better. Okay, then let's also give it some drag. So we'll take a pop drag. When you type drag, you will get 2 of them. Like this is not the one that you want to use because this is for like other dynamic stuff. So it won't work on particles. So what you want to look for is pop drag. I know I'm saying this a little late, but just remember. Okay, so let's just add a little bit of drag to this. And again, I want to randomize this. So I'll take air resist multiplied by equal to, let's do fit 0, 1. I'll randomize the ID and I'll make it 0.5 to 1. Yeah, so we should get, like, it will slow down a bit. We can adjust it to like how much you want. So the movement is fine, like I'm okay with the movement. But now they're all sort of bunched up in one place. So the way to separate them is just use a pop interact. And you don't need to do anything with it. Just add a pop interact and that's pretty much it. So what it does, it just generates like a spacing between the particles. And then you can make a few more adjustments. So if we want, we can probably lower the drag a little bit. We can increase the force scale. Maybe a little more variation. Yeah, there you go. So then just make like minor changes to make sure it all looks nice. And if you increase the position force, they'll spread out a bit more. See. You can also try to increase like the velocity force. The thing with generating something like this is you need a fair bit of frames. Okay, so what we'll do is I'm going to increase this to about 1,000 frames. But what happens is that the object stops moving after 240 because the original animation was 240. So what you need to do is you need to come back into your motion effects. We'll select both of these, come into channel and change this to use start and end and make the end value like 100. So then it will continue for the whole duration. And now if we play this, it should look a lot better. Like it'll last a lot longer. So if you want a specific motion, like maybe they're going around in a circle or you want it to move very specifically, you can also manually keyframe your object, okay, like the target object, and it will follow that. Okay, now let's make them look like fishes. Okay, so this is a bit of a cheat, but it works, okay, because it's a distant shot, so it's fine. So we'll take a trail, I'll give it about 4 or 5. We'll take an add and technically the same thing that we were doing for like making the rockets that were hitting the shield. So we're doing the same thing. So keep it to ID. And now if you play this, okay, hold on. Let's take a resample. We'll just color it. So let's make it 0.01. Do subdivision curves, curve view. Okay. And then take a color. We'll set it to curve view. Okay. And let's do one thing. Yeah, let's make this, let's try like a yellow. Okay. And we'll make that, I don't know, like a blue or something. Okay. So what you'll get is this. See. And then the next thing we want to do is we just want to give it a sweep. So even if you don't put the P scale into curve view or put the curve view into P scale, you have an option for doing like scale along curve within the sweep itself. So I can set this to round tube, and what I can do is just sort of increase it. Yeah. And then say apply curve, apply scale along curve, and then we can take a B spline for both. Yeah. And then I can just shape it. So there you go. So if you press play now, you have a simple school of fishes. And then you can try to increase the number of particles, like that's fine. So I can just come in here and let's say we'll pick up about 500 particles. Yeah. So there you go. Yeah, I think now it looks a little bit better. Yeah, there you go. See, so you get, it gets a little slow naturally because there's a fair bit of geometry now. Yeah, I think the polygons are inverted. So just, yeah, it sort of always does that. So just do reverse. I think that will be better. And then you can do like single polygon. So it fills up the sides. So yeah, so this is good enough for like long shots, and it does a pretty decent job overall. Yeah, and that's how you can make a school of fishes. All right, so the next thing we'll take a look at is we'll look at the particle orbit node, which is you can just put particles in an orbit.